Yeah. So my name is Artur, and I'm going to present you now basically a NoSQL database onto which I did put a REST API on top of this. And I think I have about 13 minutes for this talk. And I would like to ask all of you who is or has been working with databases. Please raise your hand. So almost everyone, I guess that's the reason why you're here. And I would like to, so after 13 minutes, I would like to give the first minute to you. And I would like you to discuss within a minute with your neighbor, maximum of 4 people, what is the most annoying thing that you experience when working with database. So please share your opinion with your neighbors. Got 1 minute. Maybe move closer together. Okay. I hope hopefully you didn't have any problem with the database. That's great. But I think there are some problems, and hopefully, during this talk, maybe some of the problems that you just discussed now, maybe some of this can be answered, with this database, which is strangely called, Stretchy. And I also have to say that it's my first time at a Python conference, and today is also my first day. And it's really great to be here and meet all of you, and to get to know each other. And I'm really looking forward for the social event tonight, and to get to know each other even better. And what I think is very important is that to stay in contact, stay in touch. I also don't like Facebook, obviously. So, but we're all programmers. Probably some of you have some web programming knowledge in Python. So I think we can just set up a small web application on our own. What we need is just a web application in Django or Flask, and then some database to store our contact details. And the table of this database would probably look something like this. So you put in your name and your email and your address. Hold on, something is missing. Of course, your phone number, very important. So hold on a second. I just have to stop the server, do a database migration, and then restart the server. This just takes a minute or so. Okay, here we are. So now we have a column for your phone. It's really good. But hey, did we not get these t-shirts, right? For the next conference, I would like to, we would need your t-shirt size. Hold on a second. I just add this information. Yeah, here it is. So now you can put in your shirt size. And, hey, it's not your birthday coming up soon, right? 40 years, yeah? So, I really think it's good to know each other's birthday. We can send cards and cakes. So we should also add a column for your birthday. Yeah, this just takes a couple of minutes. Okay, so we're back. And then there was this other thing that we would like to add. Okay, I think you know where I'm heading to. So, database migration is really a painful thing. If you have worked with Django or Flask, you're familiar with this. And so unless you really know upfront what you want to put in a database, in your SQL database, if you know this from the very beginning and it doesn't change, that's all fine. But if you want to add some more stuff, you have to do migrations. And imagine there's a scenario where your user or you want to put data into your database during the runtime. So dynamically create, to put this data into your database. Can you create dynamically database models in Django? I don't think so. I have not found out how to do it. But actually, So this is the problem with NoSQL. It's very with SQL. It's very restrictive or prescriptive, and this is where NoSQL comes into the game, because NoSQL is there's no scheme, there's no schema. You just put your data in. It's basically, imagine it as a store of Python dictionaries, and since we want to have this database technology agnostic, of course I'm using MongoDB because it's almost a synonym for NoSQL databases. But we don't want to tie this too much to a technology, so let's use a REST API to make it technology agnostic. And then, so NoSQL database and a REST API. There should be something available on the market or on the open source community for this. So anyone knows Elasticsearch? Please raise your hand. Yeah, I see a couple of people, almost everyone. And so I'm not so that experienced with Elasticsearch, but I gave it a try. I did a tutorial, and what I learned is when you do a put request, so to put your data in, what you get back is your data, of course. Then you get metadata about your data. Then you get metadata about your search, and you get metadata about your machine deployment. I find this a bit verbose. And on top of it, I really struggle to set this up. I find it very complex, and it's a heavy monster. And I don't like this complicated and heavy things, because I like to keep it simple. I'm a simple mind. So I thought, how complicated could it be? Let's make a simple version out of this. And that's where, Stretchy was born. And so, if you want to start it on your laptop, it's very easy. If you use Docker, you just clone the repository, go into it, and then do a Docker compose up. So it loads a bit of data. It takes a while, but then it's running. If you want to install it bare metal, make sure you have MongoDB installed, clone the repository, install the Python requirements, and run the Flask application. And then the first thing you should do is to go to your local host, port 7979, that's configurable, and to see if it's up. And you will already see some stuff here, but that's from the MongoDB database. It's just some artifacts. You can delete them or just leave it there. And so the first thing is we have this database now running. We want to put data in. So in Stretchy, I use this concept of domain and models. Well, in SQL, you would use database and tables. In NoSQL, you use, I think, database and collections. But I like more this domain model concept, because the domain is your domain of interest, could be your project or your company. And then the models is that belong to this domain, and these models, they store documents. And a document is basically looks like a Python dictionary, is a JSON dictionary. So you have your key values, entries. And so we are going to make a database of the best movies of all times in the cinema domain. We start with number 1. This is from IDBM or some other source. You can also insert more than one dictionary, a list of dictionaries, so as a bulk insert. And you can also insert, and this is the nice thing about NoSQL, the documents must not be homogeneous. You can, in this case, leave out a field and edit another field. And this gets all into the database. Then you have the replace and modify. So all these CRUD, so create, read, update, delete operations are provided. And I just want to highlight that right now it's on a document basis. So if you do a replacement, for example, you have to supply this unique ID, which I will explain in the next 2 slides. And then the new content that you want to store there. Okay, so we have now put a lot of data in, or some data in the database, and also modified it. So let's do a read request. First, you can see the domain is here now, the cinema domain. And if you go in the domain, you would see there's one model, the best movies, and I go directly now to this best movies. Not sure how readable this is, but you get back all your entries without any of the metadata. The only thing that is added is a unique ID, _ID. And this data is actually auto-generated by MongoDB, but it doesn't matter. The important thing is that there's a unique ID attached to your document that makes it identifiable. You can also see that numbers are stored as numbers, and everything else is basically a string. That actually also includes datetime objects because it must be JSON serializable. But there's so far I didn't see any limitation in this approach. And okay, if you do a GET request or a read, you get back everything, but you don't always want to have everything, of course. You want to do a filter, and for the filtering syntax to get a filtered view, you just you supply a query string. And I try to be the syntax is very much like this PyMongo library syntax, and I try to make it as intuitive as possible. So in this case, we're filtering for years greater or equal to 1940 and lower or equal to 1950. And these are the two entries that you then get back. So, okay. So far I didn't have shown you any code. I just showed you the REST client. This is actually how that's the code for the post request. So that's all. Yeah. Very short, very neat. And in fact, the whole thing is just 300 lines of code. So I'm a bit embarrassed actually to present this project here because it's really so small, but maybe this is the beauty of it, that it's so simple, but at the same time quite powerful. And the thing is then that you can basically put any kind of data that you can imagine as a Python dictionaries into this database and read it out. However, since it's not like with SQL, where everything is enforced, the data types and the things that you can put in and the relations. So here there's the complete freedom. And complete freedom can also sometimes lead to a complete mess. So you as a developer are then responsible to make sure that you're consistent with how you put the data in, that you also read them out in that way. And yeah, so basically that concludes already the presentation. And I really would like to hear your feedback, especially from those people that were using or are using Elasticsearch. Thank you.
Yes, thank you very much for the talk. I see the first question already.
Yes, thank you for this nice talk that you gave on your great Linux laptop, of course. My question would be, you said it works with Mongo internally. So, have you looked at TinyDB at all? Or, because that would be a suggestion. If you want to go even smaller, you could, so for those who don't know, it's also a NoSQL database, but it's more lightweight than Mongo.
What is the name again?
TinyDB.
TinyDB.
It's
I haven't looked into it, but I mean, this is the case. This is the idea of using this REST API that you can replace this MongoDB by anything else that then complies to the REST API syntax. You could even do this with an SQL database. There's some approaches, but it would be a bit complex. But maybe this is something that you could look into and submit a pull request.
Sure. If I may, a second question. Do you have any actual use cases of this? Because it's technically a cool concept to have a REST API with a database, but are there any like real world examples? So
let's say the marketing slogan of this would be, it's like Elasticsearch, but brutally simple. And I'm actually using this also at work. I work for ESA, and we get a lot of telemetry from the satellites, and also mostly actually for the planning. So the ground station contact times, and so we are actually, we are using this also to visualize, to store this data. And then do some calculations on the data. So we use this as a backend data store for some of our internal calculations.
Hi, thanks for the presentation. It was very interesting. I was wondering, are you familiar with Python Eve with with this project?
Yes.
And I was wondering how it compares to your project.
There's two big projects: there's Python Eve and Sandman. Both of them did not fulfill. I think it's the Sandman one, which is kind of introspective. So you connect it to your database, existing database, and then it finds out what's in there, and then you provides the interfaces to it. But that's for the Sandman. For Eve, there was another thing that really kept me from using it. I can't recall right now exactly why, but I looked into it and I found it. It's a nice project, but for my purpose, it was a bit too much.
Okay, thank you again. Now it's time for another break. And I guess for further questions, you can just come forward and ask them yourself. So another round of applause. Thank you very much.